All right, it's 8:01, always the time to begin. So thank you for coming this morning. And my little meteorological or nature tip is that, you know, the white oaks turn last, and they're just starting to turn. And some years they're only brown, but this year they're going to be a deep inky red. So if you can take some time to take a little drive this weekend, it's really a perfect time. And thanks again for taking an hour out of your day to take care of yourself and learn something more about medicine. So today we have Dr. Dennis Maki, who is a professor emeritus in the Division of Infectious Disease and Pulmonary Critical Care, and we'll be talking about the title, Emerging Infectious Diseases of the 21st Century, the Impact of Global Warming on Human Health. And as you know, I always like to give you a little bit of information about people from their CV, and every once in a while, someone is so distinguished that I actually get a little printout of the bio. But I've taken some highlights from that, and Dr. Maki said to make it brief, so I'm not going to read the whole thing. But what I am going to tell you is that he holds the Ovid O. Meyer Professor of Medicine here in the Department of Medicine in the Division of Infectious Disease. He graduated from the University of Wisconsin School of Medicine and Public Health with his MD degree, and then went on and did his internal medicine residency training at Harvard Medical Service of Boston City Hospital, where he also was a chief resident. He went on and did his fellowship in infectious disease at Mass General Hospital, and during that time, he spent 2 years as an Epidemic Intelligence Service Officer with the Centers for Disease Control and Prevention. And as all of you know, he is both an infectious disease doc, a critical care doc, and an epidemiologist. And his career has really been devoted toward prevention of nosocomial infections and the management of life-threatening infections. He has over 700 articles, 350 articles, and 700 abstracts. And his work has been cited over 18,000 times. And many of us know this, but his scientific work really has been the underpinning for the bundles for the sepsis measures that we use in our hospitals worldwide. And we just heard about sepsis a couple weeks ago here at our grand rounds. He's been highly decorated, and I want to go through just a few of those incredible awards he's received, one of which I cannot pronounce because it's in French. So in 1994, he received the CIPI Award from the National Congress of Infection Control of the Society of Pathologies of Infectious Diseases in France, the World Health Organization, and the CDC for global contributions to the prevention of infection. In 2000, he was made a Master of the American College of Physicians and was cited by the Infectious Disease Society of America for lifetime achievements in the field of infectious disease. In 2001, he received the Hilldale and Belzer Awards from our university campus here for his contributions in teaching, service, and research. In 2002, he was named to the HHS Secretary's Council on the Public Health Preparedness, and in 2015 to the editorial board of the CDC Morbidity and Mortality Week. He has been a distinguished alumni of the Medical Association in 2009, and just 3 weeks ago in 2019, he received the Distinguished Alumni Award for our University Alumni Association, which is a very coveted award. But I think really more than all of these incredible things that Dr. Maki has done is, for someone as distinguished as he is, when I think about him, it's his kindness and his compassion and his humility that make him a really unique physician, and the fact that he gives back to everyone in the state of Wisconsin and beyond, whether you're a doctor in the very smallest city in this state to a very big fancy hospital with Nobel Prize winners. And he treats all of us with the same kind of respect as a physician, and I think that's a highly unique attribute. And with that, Dr. Maki, come on up.
Pardon? I think so. It's a great honor to have the chance to do grand rounds again in my dotage. And I'll apologize in advance that I'll probably tell you far more than you ever wanted to know about emerging infectious diseases. But it's an absolutely fascinating topic, and I simply can't resist. I have no conflicts of interest, and I'm going to cover 4 major areas. We're going to talk about what are emerging infectious diseases so people understand the term is used and bandied about so commonly. Exactly what are they? Why do they emerge? And we'll spend a lot of time talking about that. And we'll spend a considerable amount of time talking about a new, very concerning multi-drug resistant fungal pathogen that's spreading rapidly around the world. That is almost unique in terms of its virulence and its resistance patterns. And we'll spend the remaining time talking about the impact of global warming on human health, and particularly emerging infectious diseases. And we'll talk a little bit about what can we do about emerging infectious diseases for prevention at the local and at the international level. Is it not on? Okay, sorry. So what are emerging infectious diseases? This is a woodcut from the Middle Ages that depicts the 4 horsemen of the apocalypse: war, death, famine, and pestilence, or contagious diseases. Hippocrates talked about a wide number of diseases we all deal with, and particularly scourges that occurred in epidemic form. This is perhaps the most distinguished biomedical scientist of the last 500 years. This is the great Louis Pasteur, who conceived the germ theory of disease. The microorganisms cause infectious disease syndromes, and actually is also the father of immunology, developing the first targeted vaccine, the rabies vaccine. Following Pasteur, there was an explosion of research. Koch came on in Germany, and hundreds of investigators characterized hundreds of bacterial, viral, and fungal pathogens that we're all very aware of today. And vaccine development proceeded at a breathtaking pace. And anti-infective development over the last 75 years has been equally breathtaking, particularly in the last decade, antivirals and antifungals. And we can take a lot of pride in the progress of understanding infectious diseases and their control over the last 50 to 75 years. In fact, we'd made so much progress that by the mid-1960s, one of our most distinguished Surgeon Generals made the observation that the United States was ready to close the book on infectious diseases as a major health threat. This was my mentor at Harvard, the great Max Finland, who was the father of the field of clinical infectious diseases, had one of the first training programs, and was my chief of medicine and my first attending as an intern. And Dr. Finland achieved international renown. By the 1950s, he was very, very well known all over the world. And he told me this story about the time I was an intern when he took my wife and I to the Boston Symphony. About 1952, a number of his friends said, "You know, it's not too late, Max. There's no future in infectious disease. We've discovered all the pathogens. We just need a few more anti-infectives and vaccines. It's not too late for you to look for another field of research." But infections didn't go away. They become a major problem and far more complex than we might have ever dreamed only 40 years ago. And every day, more patients die of an infectious disease around the world than die due to heart disease or cancer combined. By the time I started my career here in 1974, the field of infectious disease hadn't had a lot new in terms of new pathogens. Everything we were dealing with, we'd known about for 10, 15, 20 years. There'd been very little new. And the world changed in 1977 when there was an outbreak of pneumonia in Legionnaires that went to a convention in Philadelphia. The Legionella outbreak, which identified a new pathogen that had not previously been identified. It was under our noses. It's in water, in streams, lakes, and domestic water supplies, and an important cause of both endemic and epidemic pneumonia. That was quite sobering, I can tell you, to the infectious disease community. That was followed only several years later by an outbreak of toxic shock. Healthy young women developing severe shock and 15% of them dying. And here it was an old pathogen, but a new toxin related, and the disease was triggered by hyperabsorbent tampons. And this was thousands of patients across the country. That was followed only about 2 or 3 years later by the first cases of acquired immune deficiency syndrome, or AIDS, an epidemic that has not yet run its course. By this time, we were getting new infectious diseases emerging at an extraordinary pace. And about 2000, the National Academy of Sciences commissioned a Blue Ribbon Commission from the Institute of Medicine to examine the issue of emerging infectious diseases in order to make recommendations to the government on targeting of resources for control and treatment. And they defined emerging infectious diseases as one of 3 things. An entirely new pathogen that had not previously been identified and which was a significant pathogen that people had to deal with. Or the reemergence of a well-established pathogen that had been controlled but now had become a major problem. Or anti-infective resistance on a major scale. So what are the emerging infectious diseases of the early 21st century? This is a list I've updated from an editorial I wrote a number of years ago, and every single infection on this list was not known when I was an intern, about 50 years ago. These have all appeared in the last 50 years, most of them in the last 30 years, which I find quite sobering. And these are not rare, exotic diseases. There are many, many common diseases we deal with every day, all of us. And the field of emerging infectious diseases has literally exploded. So to me, one of the most fascinating questions about this whole field is, why have these emerging infectious diseases emerged? And there are many reasons, and in most cases, there are more than one reason why an emerging infectious disease becomes preeminent, and we have to deal with it. Let's look at some of them. We've known for a long, long time, when you have major societal disruption by war, by famine, by extreme weather, you have large numbers of people who are displaced, and there is greatly increased vulnerability to infectious diseases, particularly waterborne and foodborne infectious diseases, reactivation of tuberculosis, meningitis on a major scale. In sub-Saharan Africa, where we're seeing this, there are hundreds of thousands of cases of bacterial meningococcal meningitis every year, the meningitis belt of Africa. And there's obviously kwashiorkor, there's famine on a huge and devastating scale. Changes in healthcare, which are familiar to all of us here today, have had an enormous, enormous impact. When I started my career as an intern, the concept of hospital, I never heard a lecture, never even heard anybody talk about hospital-acquired infections or nosocomial infections. So when I was drafted out of my residency as a PG2 and sent to the CDC, they sent me to this new division called the nosocomial infections branch. I didn't have any idea what it was. Hospitals didn't have any infection control. And that was 1969. Well, if we move fast forward 50 years, we've learned that patients in hospitals and nursing homes are extraordinarily vulnerable to infectious diseases. And line-related bacteremia that I've devoted most of my research career to, ventilator-associated pneumonia, surgical site infections, C. difficile, and then these new pathogens. We didn't know anything about MRSA. Coag-negative staph was not really thought to be a pathogen when I was a house officer. Vancomycin-resistant enterococcus has come, and then multi-drug resistance and the appearance of fungi and viruses in immunocompromised patients on a huge scale. If we look at one of the major advances in healthcare, it's medical implants. Many of us here have a medical implant. I have 5. I have 2 prosthetic hips. I have a carpentry ring in my heart from a ruptured chordae. And I have 2 artificial lenses. And I can assure you, they've greatly improved the quality of my life. But the downside with implanted medical devices of all types is infection. And although we've made a lot of progress on controlling and preventing infection with implanted devices, they still occur on a daily basis, and we have to deal with them. And they're devastating infections that often require explantation of the device for control. And we've learned that organisms from the skin that were rarely human pathogens are very important pathogens in these infections and are formidable pathogens and difficult to treat. I'd like to talk about an important new nosocomial pathogen that we are now being forced to confront. And it is part of the emergence of multi-drug resistant fungi, which is an important new emerging problem. Candida auris. Candida auris is a Candida strain that was first identified in an isolate from otitis externa in 2009 in Japan. And then they had 3 cases of invasive disease in Korea. That's only 10 years ago. Over the last 10 years, it has spread like wildfire. And it's now been reported in countries all over the world. And in the United States, we're probably pushing 1,000 cases now. Almost all of them are since 2015. 90% have occurred in New York City, New Jersey, and Illinois. Illinois is pretty close. This is a fungus that can be difficult to identify in a hospital lab. It's often missed by some of the commercial identification systems. Fortunately, the new mass spec system, the technology used for identifying most of our pathogens now, can identify it accurately. It is very virulent. It causes line-related bloodstream infections, pneumonia, urosepsis, surgical site infections, otitis media. But what's unique about it, it has a propensity to cause invasive disease exclusively in debilitated, vulnerable patients. I look on it as the wolf of the elk. The wolf pack looks for the weak, the older animal that's starting to fail and takes it down. That's what Candida auris does. It's multi-drug resistant, uniformly resistant to fluconazole, even resistant to amphotericin up to 1/3 of the time, and up to half the time to important triazoles, but it is fortunately still susceptible to an old antifungal 5-FC and to the new triazole isovuconazole and to the echinocandins, which are the cornerstone of treatment. But this kind of resistance is just almost unheard of with Candida. It makes very heavy biofilms with high-level pan resistance. In a biofilm phase, it's usually resistant to everything. So if you have a biofilm on an implanted device, it's got to be removed. There's no natural source of this organism in nature. The sophisticated molecular studies suggest it probably emerged 4,000 years ago. There's 4 international clades, and all of them have been seen in the United States. But it was selected out by very heavy use of antifungals. It found the perfect setting to spread and proliferate and perpetuate its genes, the drive of all living cells and creatures. And that is hospitals and nursing homes where there's a lot of antifungal pressure that eliminates competition from bacteria and other fungi. Heavy use of antifungals in agriculture, which we'll talk about shortly, might play a role as well. When a patient gets colonized by this organism, it's usually indefinite. And there's little colonization of healthcare workers or healthy patients. And it contaminates literally every site in the room you can find the organism. And it's very hard to eradicate. You can aerosolize hydrogen peroxide and the surfaces still remain positive. And it's very, very difficult to eradicate from the environment. And the environment's probably very important in the perpetuation and spread of the infection in hospitals and especially ICUs. In the UK, 20 major hospitals have been afflicted. They've had to close down ICUs. It's had a huge impact. It spreads person to person and environment to patient and hospital to hospital. And this shows New York City hospitals. They're sending patients back and forth on a continuing basis every day. Every hospital in New York City has got Candida auris. It's understandable why. And the number of outbreaks has just increased almost exponentially. Fortunately, it's susceptible to common disinfectants, but chlorhexidine bathing does not eliminate skin colonization. When we treat, we start with an echinocandin, with or without amphotericin or 5-FC, and we refine the regimen by susceptibility testing, follow-up cultures, and we can follow the new marker beta-D-glucan levels. Control requires a huge commitment of resources for a hospital, and in the UK, at the Brompton Hospital, they literally, every day, they had to move the patients out of the room and literally sterilize the surfaces to achieve control. What's even more scary, we'll talk about shortly, is azole resistance in aspergillus. That's now occurring on a significant scale that most of us thought would never happen. Because aspergillus comes from the environment. Where's it going to get exposed to antifungals? It doesn't spread person to person. However, there's another issue. This brings me to the issue of food production. When I grew up in northern Wisconsin a half-century ago, a child of the 50s, food production in the United States and the developed world often came from literally millions of tiny farms with a pastoral setting, the cows grazing peacefully in the pasture. My grandfather's farm milked 25 cows. He was a big-time farmer. Well, today, you don't make it as a dairy farmer in Wisconsin unless you milk at least 200, and it's probably better to milk 1,000. And there are farms that milk 5,000. When you got 5,000 animals, you got a lot of manure. And that plays a very important role in what we're seeing in emerging infectious diseases. But the industrial production of food has actually been remarkably efficient. It's how we can feed 400 million people in North America and 6 billion people around the world. But it's a challenge because a breakdown in the process anywhere can result in literally hundreds of thousands or even millions of patients being exposed to a contaminated foodstuff. And the incidence of foodborne diseases has actually risen in the last 25 years. And we've got foodborne diseases on a major scale, and we have new pathogens such as Shiga-toxin E. coli or listeria. There have been over 100 outbreaks of listeria infection as foodborne disease only in the last 25 years. And we've got Candida auris, which we'll talk about. We are now seeing azole resistance of Aspergillus fumigatus. Why did it occur? Because there has been an enormous upsurge in the use of antifungals in agriculture on crops. And Aspergillus is a plant pathogen. Aspergillus is in nature, widely spread in nature. It grows on moldy plants, it grows on dead leaves, wood, and when you start using azoles in agriculture, it has selected out azole-resistant aspergillus, which is not a trivial issue because the most important advance in the management of invasive aspergillus infections in our lifetime has been the azoles. They have markedly improved the capacity to treat very desperately ill, vulnerable patients with invasive aspergillus infection. That's now being challenged on a major scale. Changes in human behavior. The sexual revolution of the 1960s was followed by a massive global epidemic of sexually acquired infectious diseases. And gonococcal infections resistant to antibiotics have skyrocketed. We've had rampant syphilis. Herpes came out of nowhere, and 50 million Americans have herpes progenitalis. And I don't have to talk about HIV infection and AIDS as a sexually acquired infectious disease, or HPV-induced cervical cancer. Illicit drug use, which is skyrocketing as well, unfortunately, has resulted in important new diseases that literally were unknown only 40 or 50 years ago. Staph aureus endocarditis is literally an epidemic in Madison. I'm on the ID consult service this week. It's a rare week we don't see at least 2 or 3 patients with Staph aureus bacteremia, most commonly associated with illicit drug use. That used to be thought of, well, that's Detroit, or that's New York City. Madison now has got plenty. And complex necrotizing soft tissue infections, hepatitis B and C and HIV, opioid overdoses, 70,000 deaths in 2018, and the tragedy of drugs on young people. International travel, 1 billion passengers fly internationally every year. That has accelerated the spread of diseases that were normally restricted to certain areas of the world, and these have spread now as a consequence of international travel. Microorganisms can adapt. Influenza is the quintessential adaptive viral pathogen and has been changing its genome on an ongoing basis for millions of years. But we've had the appearance of virulent strains of Staph aureus that produce unique toxins, the same for group A strep. Multi-drug resistant bacterial infections are increasing at a rapid pace, and we've had the appearance in the last 20 years of hypertoxigenic NAP1 C. difficile, which has had a great increase in mortality, and then Candida auris. The public health infrastructure is a thin veneer of protection against many, many diseases. And when we underfund the healthcare system, or we let vaccines, when vaccines are not used the way they should be used, bad things happen. This is a good example. Many of you may remember glasnost and the Soviet Union. They decided to abandon the socialistic economy, have a free economy system, and their economy collapsed totally in the effort to do this. And for about 5 years, they collected no taxes, and they stopped immunizing their children in about 1988, 89. They just didn't have any tax money. Within 2 years, they had 50,000 cases reported of pharyngeal diphtheria, an enormous increase. Within only 2 years of stopping immunization. We don't realize how important immunization against childhood diseases is in protecting our children. Well, in our country, we're now facing the return of measles on a significant scale because of people opposing the use of vaccines for not very good reasons, and a lot of myth and, quote, fake news. This brings us to the return of child exanthems, meningococcal disease, college students dying of meningococcal disease because they weren't immunized, and people not wanting to immunize their daughters and sons for HPV, realizing that the end stage of the disease is cervical cancer. Finally, environmental changes. What you're looking at is the great Amazon rainforest, of which a area the size of Rhode Island is burned every month. We don't realize that this is actually a powerful shield against global warming by consuming CO2. And we're destroying it at a frightening pace, not only in the Amazon, but also in Asia, Sumatra. This has been shown to put people living in these areas at increased risk of malaria, dengue, mosquito-borne diseases, and global warming. Flooding, which is occurring on a major scale because of extremes of weather, greatly increases waterborne diseases, especially diarrhea of infancy and enteric infections of all types. Here's a wonderful example of emerging enteric disease due to flooding that we can all identify with. The huge outbreak of cryptosporidium infection in Milwaukee about 25 years ago. It was a spring where there was a lot of rain, there was flooding, washing manure off the fields into the rivers and streams, and the rivers that emptied into Lake Michigan within a mile or two of the intake of the municipal water system in Milwaukee. And there was a tremendous increase in turbidity after a lot of rain and flooding, and that was followed by a huge epidemic involving nearly 500,000 cases of cryptosporidium enteritis and a lot of deaths in patients with AIDS who could not be cured of this infection. The rural area of sub-Saharan Africa, when I grew up, sub-Saharan Africa was many little small pastoral villages that didn't have all that much communication with each other. The Africa of today is very, very different. One of the big changes in Africa has been the enormous urbanization. The urbanization of Africa has literally exploded, and the majority of Africans now already live in large cities, not in little villages. By 2050, probably 10 of the largest cities in the world will be in Africa, over 10 million each. This has translated to the rapid spread of AIDS and Ebola. There have been a number of Ebola outbreaks in Congo over the last 35 years. The most recent one has now exceeded almost 3,000 cases and is still not totally controlled, primarily because of urbanization. In North America, we have a different problem. People want to live out in the country, be close to nature, which puts us at risk of mosquito-borne diseases, tick-borne diseases, like West Nile virus and like Lyme disease. Our tick-borne disease is on the increase. I showed this at a grand rounds last year. The evidence is overwhelming. The incidence of Lyme disease has increased over twofold over the last 25 years. If you look at, this is Rocky Mountain spotted fever, and it's very, very clear. If we look at other parts of the world, tick-borne encephalitis is a devastating tick-borne disease that's endemic across Europe all the way to Asia, and it's a much more severe tick-borne disease. The incidence has gone up markedly. Why? Well, a lot of people would suggest it's due to exposure because we're living closer to nature. Is it the deer populations? That's what people would have thought. It really is not, interestingly. It turns out that the field mice are the key host in the cycle of our vulnerability, and the field mice have been controlled by predators. And when predator populations decline, as they have in the last 25 years, there's been an explosion of mice, which has been followed by a parallel increase in ticks and tick-borne diseases. And global warming is going to have a huge impact on tick-borne diseases. We'll see very shortly. So let's talk about global warming to finish up. We've had pretty good data on mean global temperatures for the last almost 150 to 200 years. And it's very, very clear that beginning about 50 years ago, the mean global temperature started to rise very, very substantially. We're up to almost 0.8 of a degree Celsius, which is a very significant increase and has big consequences. Now, we've had periods in geographic history, literally going back millions of years, where there have been periods of global warming, and there have been periods where it's gotten very cold and we've had ice ages. That's very clear. And the Pliocene period of a couple billion years ago, there was tremendous global warming, and the sea levels were 30, 40 meters higher than they are today. The big issue is the global warming a natural phenomenon, or is it related to human activity? That's really the fundamental issue. And it's very clear we have global warming, but what's been most striking, it has directly paralleled CO2 concentrations in the atmosphere. And CO2 is generated primarily by burning of fossil fuels. The argument has been, is that the major cause of global warming? Because if it is, things are getting worse and we better do something about it. The temperature extremes are really quite concerning. The last 5 years have been the warmest 5 years we have on record by far. And it's very, very clear that most of this CO2 increase is human generated. And the model, very simply, is greenhouse gases, particularly carbon dioxide, but other gases that are generated in industrial production prevent radiation of solar heat back into the atmosphere, and they basically keep it on the surface of the Earth. That raises the mean temperatures. What's most striking is that the ocean absorbs 90% of the heat generated from global warming. If it didn't, our mean surface temperatures, we would be up almost over 50 degrees over the last century. So when the temperature of the water starts to rise, bad things happen. There's a significant impact on things like the Gulf Stream and ocean currents, which modulate weather and will contribute to weather extremes. Absorption of CO2 in the water increases the acidity, which accelerates loss of coral and marine life habitat. We've had I can only say breathtaking loss of sea ice. The melting of the Antarctic and Arctic ice cap has occurred at a far more rapid rate than most people could ever dream. And when you lose sea ice, you have dropping krill levels, declining fish populations, polar wildlife and seabird populations. All these things we are already seeing on a very significant scale. This is not projection. This is real life. If we look at our global energy production, 90 to 95% is still fossil fuel. and there's been very little impact. We've had some impact on use of coal, but not a huge amount. And the amount in terms of oil and gas, we've had a 500% increase in use of fossil fuels in the last 25 years alone. And the impact of trying to generate green energy where we don't produce CO2 has been very, very modest. And these are some estimates of the impact on CO2 generation if we make a major effort or we do nothing. And we are basically not doing very much. There's a lot of talk, and WHO is very concerned. Most governments in the world are very concerned. There have been meetings and conferences and promises and pledges, but the reality is not much has happened. And if nothing happens, once we get up to about 2 to 3 degrees of increase, it will be catastrophic, as I'm going to show you shortly. So this is where we'll finish, the impact on global health. Now, if I'm going to talk about the impact of global warming on human health, I come back to this very famous phrase from my hero, Isaac Newton, who was an extraordinary man, who once said, "We stand on the shoulders of giants, anything we might achieve." I couldn't talk about global warming without talking about Jonathan Patz, who is our university's Nobel laureate, who is a very distinguished expert on the effects of climate change and human health. He is a professor of population health here on this campus, a remarkable man who's had a terrific career. The first thing that will happen as the temperature rises, it's already happening, is marked increases in insect-borne, fungal, and waterborne infectious diseases, but particularly insect-borne diseases. Jonathan pointed this out over 20 years ago. These are important vectors of human disease, and there are a lot of vectored human diseases. Millions of cases, 500,000 children die of malaria alone in the world every year. And almost all of these vectors thrive with higher temperatures. They will survive. Their habitat range broadens. It's very, very clear as we've got global warming already. Schisto range in China has extended markedly, and malaria is increasing markedly. Tick-borne diseases are increasing, I've showed you. If we look at malaria, within 10 years, malaria will be endemic in Europe and North America, almost certainly, at our current pace. But what's probably equally important, even more important, is when we have a tremendous increase in insects, the impact of insects on crop production and being able to produce food for 6 to 7 billion people could be very much affected. The second thing is wide-scale microbial contamination of streams, rivers, and oceans, mainly related to environmental extremes, and higher water temperatures allow microorganisms to proliferate to high levels. This has already happened on a major scale, and all you have to look at how often they close the lakes to swimming now because of high coliform counts. It's here, and it's going to get worse. Massive oceanic lake and river algae blooms and toxic illness and massive fish die-offs already being seen. This all turns into major shortages of safe drinking water and rampant waterborne infection, including cholera in the developing world. Crop failure and famine from insects, desertization, and weather extremes and drought. It's all happening already. Heat stress illness and asthma, high ambient temperatures greatly increase aerosol allergens in the atmosphere. and rates of active asthma increase. And heat stress is most important in terms of vulnerable infants, elderly, and the chronically ill. And this is data from the military. Healthy young soldiers, heat stroke is actually increased very substantially in military training facilities because of the increase in days with very high temperatures. There can be 500 excess deaths in a large municipal city on a day where the temperature might be 107 degrees. Increased mental illness, suicide, and societal aggression is directly related to high ambient temperatures. Massive hurricanes and flooding, this is already happening. We're having much, much larger storms than we have ever had. As the oceans store heat, this is the incubation of huge, huge hurricanes. In the last 10 years, we've seen more large hurricanes than had been recorded in recent history. And the storms are getting bigger and more frequent. Massive hurricanes and flooding and huge forest fires. And the number and size of forest fires has increased very substantially in the last 10 to 15 years. Massive losses of wildlife and diversity of living species. I just read an article early this morning that the Audubon Society predicts that at our current rates, by the year 2030, we could lose 300 species of birds could go extinct. Orioles are particularly vulnerable. The polar bear may become extinct in the lifetime of many of the people here today because they really rely on a lot of ice to capture their seals. Rising oceans and inundations of thousands of seaside cities. Levels of water, of ocean water, are rising continuously, and like all of these changes, it's not just linear, it is exponential. And if we do nothing, by 2030, it'll probably rise 2 to 3 meters. If we do nothing by 2030 to 2050, by 2100, we could be looking at 10 meters of rise. What's the impact of ocean rise? Half of the world's population lives within 60 kilometers of the sea. And these black areas on this map are areas that if we had a rise of 3 to 4 meters, it basically would inundate these cities. And the impact on basically relocation of people and homelessness, loss of cropland, will be enormous. And so what can we do about all this? Well, one of the most terrible days in our history, certainly in our lifetime, was 9/11. And 9/11 was followed by somebody sending and weaponized anthrax through the US mails. And this was a terrible, terrible time. I can remember so very well. I had to go out to New York City to do rounds at Cornell 1 week after 9/11, and I stood in the Detroit airport, and I could have shot a shotgun down it because there was nobody there. There was only one other person on my airplane. And it just had a devastating impact. So it was an awful time. This is a famous aphorism that goes back 500 years. This new wind that blows no good. It basically, to paraphrase, the most terrible event might have a bright side. And 9/11 did have a bright side. It made us realize how extraordinarily unprepared and vulnerable we were to terrorism and to bioterrorism. And more dollars were appropriated by the US government for public health over the next 5 years than had been over the last preceding 30 years. And we developed detailed, complex plans and preparations to deal with terrorism, bioterrorism. We've done pretty darn well in preparing for terrorism and for bioterrorism and for emerging infectious diseases. Preparing for bioterrorism is basically preparing for emerging infectious diseases. Our problem is we've accomplished almost nothing in terms of global warming. So I close with, what will you do to avert international catastrophe from global warming, particularly since it's already here and the sequelae are already being seen on a wide scale? Thank you.
Let's open up for questions.
I hope I've not made everybody depressed.
Anyone have any? Yes.
Regarding the Candida auris and the nosocomial infections, is it possible to use radiation to sterilize these groups? And how important is radiation for the food chain safety?
Well, in terms of radiation, I don't think radiation is going to be useful for control of Candida auris because most microorganisms are far more resistant to radiation than we are, or our cells or mammals are. And the amount of radiation you have to give to sterilize the environment, I don't think that that's going to help there. But on the other hand, you raise a very relevant point. If you look at foodborne disease, I've written 2 editorials for the New England Journal in the last 20 years about foodborne disease. And in both of them, I raised the question, why on earth are we not using radiation to make food safe? The evidence is overwhelming that radiation to food is highly effective at eliminating pathogens. You can give a lot of it, run the food through, and you can sterilize a huge load of food for a very small amount of money once you have the infrastructure built. And it's highly effective. It does not alter the food, does not make it radioactive, it doesn't create carcinogens, and it makes the food, literally eliminates any pathogen that may be present. Yet people, it's a buzzword, radiation sterilization. Every professional organization that deals with food safety, starting with WHO and CDC and going down, have all supported and advocated the use of radiation for sterilization of food. Yet it's used for only a very small amount of our food. And most, in this country, you have to put a sticker on it that says it's been sterilized by radiation, which bothers a lot of people. If we made it mandatory that all fresh food, fruits and vegetables that come raw, that you have to wash, that commonly are contaminated, meats, eggs, had to be radiated, rates of foodborne disease, I think, would unequivocally markedly drop, and will tremendously reduce epidemics of foodborne disease. It illustrates something that we've learned a long time about public health and about even changing what we do in our daily lives to try to better society. We got a pretty good idea what we need to do. It's awful hard to implement it. It's hard to get laws passed. It's hard to make it happen. Ideas are cheap. Making it happen is tough.
Other questions? Yes.
I wonder if you feel that physicians in this country have a duty.
Can you repeat it?
Be in the street, so to speak, with respect to the inevitability or the near inevitability of global warming. I feel that American physicians have a mistaken idea of professionalism in which they often feel
So I'm just going to repeat that. So the question was, do you feel that physicians have a responsibility to speak out about things like global warming when our perception of sometimes professionals as physicians is not to really speak out on these social issues?
I think we absolutely should speak out. I seriously contemplated distributing a list of all of our congressmen and how you can reach them. Their cell phone numbers, I don't have the cell phone, but their office numbers, their emails. If I had their cell phone numbers, I assure you I'd give you that as well. But we should write to our congressmen. I've had friends who went to Congress, and what they've told me is that if they get 20 letters about an issue, it has their attention, serious attention. You get 100 or 200 letters, they're alarmed. They're very, very concerned. So that we can have an impact, but how many people here have ever written a letter to your congressman?
About global warming.
That's great. That's great. That's more than I would have thought. I'm heartened by that. We should all be willing to write our congressmen about issues we care about. And we should care passionately about a number of these issues. They're very important. I'm, like many of us here, I am deeply concerned what's happening in our administration right now and where our government is going. I mean, it's frightening. And boy, Congress better get going, because Congress, it all lies with Congress if something's going to happen to try and solve our problem, because we've got a national problem.
One last question, yes.
I was just curious, and this is for both of you, what is our institution and our department doing regarding sustainability and waste that directly impacts this issue?
Okay, the question about sustainability and waste. So I can take that, Dennis, if you have any comments on that. I think that our department itself and Department of Medicine has not done a good job with that at all. I think that UW Health has done a much better job lead characteristics. We've gotten a couple awards for what we've done in new design to help with saving our resources, but that's something that we could look at in the Department of Medicine because we've not done a good job there.
How many people here have a hybrid car? Okay, that's a good place to start.
Bicycle's better.
Well, electrical car I think is probably even better, but the problem with electrical car is that we still don't generate enough electrical energy from green sources. Too much of it is generated by fossil fuels. So
MGE is 70% fossil fuels.
Pardon?
70% fossil fuels from MGE.
Yeah. But hybrid cars, I think, are potentially beneficial because you're generating a lot of your own electricity.
Thank you
Thank you very much.